Okay, the next part for our discussion is carbohydrates. And finally, we'll finish my part on tomorrow. And then my colleague Mohammed will continue proteins and DNA. Now, here in carbohydrates, we'll see the function of carbohydrates, definition, and how carbohydrates can. And we'll see also some of the biological importance of carbohydrates, like simple sugars, disaccharides, oligosaccharides, and polysaccharides. These are some of the functions of carbohydrates. Okay, our body can use as immediate source of energies carbohydrates. It can act as a storage form of energy for our body in the form of glycogen. Carbohydrates also serve as structural component. Carbohydrates, all carbohydrates, all carbohydrates, what we eat may not be digested. The non-digested part of carbohydrates are named as fibers. These are roughage form of carbohydrates, which is non-digestible, but it has its own role in our health in order to maintain or to reduce constipation, or it can protect us from different cancers like colon cancers and so on. Even taking enough amount of fibers also good for our health in order to reduce our blood glucose. We'll see later their mechanisms. Carbohydrates also act as a constituent of nucleic acids. Carbohydrates are very crucial for cell signaling, cell-cell interactions. Even our blood group substance, okay, those antigens which is found on the surface of red blood cell membranes are nothing but they are carbohydrates. Therefore, carbohydrate content plays a determinant role for our blood grouping. ABO blood grouping type is totally dependent on what? The carbohydrate moiety. The carbohydrate moiety can determine our blood groups. And an individual may belongs to blood group A, or it may belongs to blood group B, or it may belongs to blood group AB, or it may belongs to blood group O. What determines it? The carbohydrate moiety determines whether an individual belongs to blood group A or B or AB or blood group O. When we see, let's see, summarize function of carbohydrates. One is it is an immediate source of energy for our body, especially our nervous system. Our nervous tissue prefers to use carbohydrates in the form of glucose as preferred energy source. Our brain, our nerves utilize glucose as source of energy. Red blood cells, since mature red blood cells lacks mitochondria, it depends on totally on glycolysis as source of energy production in the form of ATP from glucose. Even our brain prefers to use glucose as energy source, but after long period of starvation, our brain also utilizes what? Ketone bodies as source of energy. Ketone bodies are nothing but it belongs to lipids. Okay. Ketone bodies are three types. These are acetone, acetoacetate, and beta hydroxybutyric. These three are nothing but they are called ketone bodies. Now, acetone, among these three, acetone it is volatile acid. Okay, it is volatile acid, but the rest, acetoacetate and beta hydroxybutyric, are their organic acids. If it is accumulated in our body, it enhances what? The acidity of our body pH value. And individuals which have high amount of ketone bodies will have to develop acidosis. But the cause is what? Accumulation of ketone bodies. Now, individuals are considered to develop ketoacidosis. The acidosis, the cause is ketone. Now, our brain in under prolonged starvation, we'll try to use ketone bodies as source of energy. But the preferred fuel for our nervous tissue under normal conditions are glucose. Now, when this excess glucose, whenever we eat enough carbohydrates, we will get excess glucose, and this glucose can be stored in the liver as well as in muscles. The other function of አልጨረስኩም። ትንሽ ጠብቀኝ አልጨረስኩም። Okay, the other function of carbohydrates is that carbohydrates is helpful for sparing our body proteins. You know, our proteins can have its own functions. Some proteins may have structural role, some can act as hormone, some proteins can act as an enzyme. Every protein in our body has their own functions. But if someone under fasting stage or under starvation stage, he may not get enough amount of carbohydrates. At that time, how nervous tissue will get glucose? Hence, he didn't eat enough amount of carbohydrates. Then our body can have other means to maintain at least some basal range of glucose in our body. In this case, we do have gluconeogenesis. Gluconeogenesis means it is synthesis of glucose from non-carbohydrate sources. In this case, body proteins will be degraded and will form amino acids. From these amino acids, our body through gluconeogenesis can make what? Glucose within the liver as well as the kidney. That means if someone eats more than 100 grams of carbohydrates per day, he will not be exposed to degrade his body proteins to make glucose. Therefore, taking enough amount of carbohydrates is good for sparing body proteins. The other role of carbohydrates is that carbohydrates prevents ketosis. That means carbohydrates are an anti-ketogenic factors. This is because carbohydrate is required for complete metabolism of fats. Let's see the overview of how fats can be metabolized in our body. When fats or lipids can be stored in our body, mainly in adipose tissue, in the form of triacylglycerol. When this triacylglycerol is hydrolyzed, it will form glycerol and 3 fatty acids. Now, when fatty acids undergoes beta oxidation, our body will get many amount of ATP in the form of NADH, in the form of FADH2, or in the form of acetyl-CoA, or in the form of ATP. Now, when fatty acids are metabolized or oxidized, the end product will be acetyl-CoA, for example. Acetyl-CoA, when fats undergoes catabolism or oxidation. Now, acetyl-CoA, to produce high amount of ATP, it should be taken into TCA cycle. In TCA cycle or Krebs cycle, acetyl-CoA reacts with oxaloacetate to form citrate, and then the pathway or the cycle will continue. And from one acetyl-CoA, 3 NADH is produced, 1 FADH2 is produced, 1 GTP is produced. Now, practically, 1 NADH is equal to 2.5 ATP. 1 FADH is equal to 1.5 ATP. 1 GTP is similar to that of 1 ATP. Now, from one acetyl-CoA, large amount of ATP can be what? Produced. When acetyl-CoA combines with what? Oxaloacetate. This leads to what? Complete metabolism of fats. But if there is no carbohydrates in our bodies, if there's no carbohydrates in our bodies, fat metabolism is incomplete. Why? Because still our nervous tissue needs to have what? Glucose. Then, from pyruvate, from oxaloate state, our body can make what? Glucose through gluconeogenesis. Now, under starvation, under fasting stage, the amount of oxaloate state becomes what? Decrease. Since it will go to what? Gluconeogenesis pathway. Therefore, when fats are oxidized, there is accumulation of what? Acetyl-CoA. There is accumulation of acetyl-CoA, and there we do have less oxaloate, which is expected to bind with acetyl-CoA. And the amount of oxaloate will go to gluconeogenesis pathway, and there is a high accumulation of what? Acetyl-CoA. From this acetyl-CoA, our body can make what? Ketone bodies. And individuals will develop ketosis if there is inadequate supply of carbohydrates. If we supply enough amount of carbohydrates, individuals are prevented from ketosis, since there is fat oxidation will be complete. Now, how we will correlate carbohydrates and health? Many high sugar foods are source of empty calories, like cakes, cookies, and candy, may increase the risk of what? Dental caries. It may affect the health of our teeth. Excess calorie of carbohydrates may lead to overweight, or it contributes to obesity. And obesity is one of the greatest factors for different metabolic disorders. The high sugar intake also can affect our lipid body profile, and it may lead to what? Heart disease. These are some of the diseases which is due to overconsumption of carbohydrates. It is better to take enough amount, but not in excess. This is due to deficiency of carbohydrates. Individuals, as I mentioned earlier, may develop what? Ketosis, if he didn't take enough amount of carbohydrates in his diet. And individuals may also develop what? Hypoglycemia. The amount of glucose in our blood may be what? Less than the normal range, and individuals may develop hyperglycemia. Now let's go to directly with definition of carbohydrates. Okay, definition of carbohydrates. Carbohydrates are nothing but it's one of the forms of biomolecules, and it is organic compounds which has carbon, hydrogen, and oxygen. Some carbohydrates may have nitrogen and other elements also. And carbohydrates are derived their name from misleading concept. Okay, from misleading concept. The term carbohydrate, for every carbon there is what? Water molecule. It seems like that. Okay, but this is not such the true definition of carbohydrates, because for every carbon there may have what? One water molecules. For example, glucose is written as C6H12O6. For 6 carbon there is 12 water molecules. To mean for every carbon there is water molecules. Okay, it is due to this, its name sometimes individuals say it's derived from carbohydrate, but this is not the perfect definition of many carbohydrates, since many carbohydrates do not have the same proportion of water. For example, deoxyribose, which is a component of DNA, and the other is ramenose, okay, which do not fit this empirical formula. But even certain non-carbohydrates, okay, they may fit this formula, but they are not belongs to what? Carbohydrates. Now, what is the best definition of carbohydrates? Carbohydrates can be defined as it's an aldehyde or derivative of polyhydric alcohols. It has many OH groups on it, and it has 2 functional groups. It may be an aldehyde group, or it may be a ketone functional group. This is glycerol, for example. This is structure of glycerol. It is a polyhydric alcohol. It has 3 OH, and if it has an aldehyde functional group, it belongs to what? Aldose. Or it has keto functional group, it belongs to what? Dihydroxyacetone. Now, glyceraldehyde it is the simplest aldose of carbohydrate, and dihydroxyacetone is the simplest ketose. And in our diet, carbohydrates constitute around 60%. When you see the classification of carbohydrates can be classified into 4 groups or can be classified into 2 groups. One is simple sugars or simple carbohydrates, and the other is complex carbohydrates. Simple carbohydrates are carbohydrates like monosaccharides and disaccharides. They are sweet in taste, whereas complex carbohydrates, these are oligosaccharides and polysaccharides. We have many ways of classifying carbohydrates. One is based on number of sugar units in total chain. If a carbohydrate which has one single sugar unit, it's named as monosaccharide. If it's 2, disaccharide. If it has 3 up to 10 sugar units, it becomes oligosaccharides. If it's more than 10, polysaccharides. Now, which bond is responsible for the formation or binding of 2 sugar units to form disaccharide bond? It's glycosidic linkage. Now, if a monosaccharide will undergo in aqueous solution, no more what? Hydrolysis. Okay, no more formation of other simple form of monosaccharides. Whereas disaccharides under aqueous solution, it will form what? Hydrolyzed into 2 monosaccharide units. If it's poly, it will release what? Many number of monomeric units. When you see monosaccharide subclassification, based on number of carbon atoms, it can be triose, tetrose, pentose, hexose, and like that. Based on their functional group, it may be an aldose or ketose. These are some of the examples of aldose and ketose. Glucose, galactose, hexose in nature, and we would have the same chemical formula, C6H12O6, but fructose it's ketose, carbon, glucose, galactose, and mannose, they are aldose since it has an aldehyde functional group. Let's see some examples. Okay, for example, a monosaccharide which has 3 carbon atoms are called triose. This can be an aldose or it can be ketose, like glyceraldehyde and dihydroxyacetone. These are intermediates of glycolysis. Okay, and glyceraldehyde and dihydroxyacetone is a precursor of glycerol. Okay, that means our body can make what? Lipids from glycerol. Even our body can make what? Glucose from glycerol. From glycerol, our body can make what? Glucose. As I mentioned earlier, we do have a pathway called gluconeogenesis. Gluconeogenesis means it's formation of what? Glucose from non-carbohydrate sources. These non-carbohydrate sources are, which are a precursor for synthesis of glucose. One of them is glycerol. And the other may be propanoic acid, pyramide, lactate, gluconeogenic amino acids. All of this can able to be a good precursor for the synthesis of glucose by gluconeogenesis. And the other is D-ribose. It is structural element of nucleic acids, and it's part of RNA or part of enzymes. And the other is hexose. Example, glucose. Okay, it is the main sugar in our body. We'll see later one by one. Okay, these are some of the pentose. Okay, it has 5 number of carbons, like ribose and 2-deoxyribose. These are some of the important functions of pentose. And let's see now isomerism. Okay, isomerism, it can be enantiomers, it can be anomers, it can be optical isomers, or it can be epimers, or it can be functions. That means aldose ketose isomers. For example, aldose ketose isomers like glucose and fructose. Glucose, it has C6H12O6. Fructose, the same chemical formula, but glucose is an aldose, whereas fructose is ketose. Therefore, two isomers are same chemical formula, but they differ in terms of structures, mainly on their functional group. It is called functional isomers, or aldoketose isomers. When it's the property of monosaccharides, the first property is optical isomerism. Optical is it's nothing but all monosaccharides except the dihydroxyacetone. What's the simplest ketose? The simplest ketose is dihydroxyacetone. The simplest aldoses are glyceraldehyde. Now, all monosaccharides except dihydroxyacetone contains at least one asymmetric carbon, and it can exhibit optical isomerism. Asymmetric carbon means it is a carbon which binds with 4 different atoms. For example, if a carbon which binds with A, B, D, E, okay, this carbon is considered as an asymmetric carbon or chiral carbon, a carbon which binds with 4 different atoms. Now the criteria is whether the molecule has asymmetric carbon or not. Since dihydroxyacetone from the structure itself, it lacks one, an asymmetric carbon. Therefore, it will not exhibit optical isomerism. Now, the simplest aldose is glyceraldehyde, and glyceraldehyde is a model, it is a parent compound to designate the rest molecules. D or forms. If in terms of glyceraldehyde, since glyceraldehyde has 3 carbons, the first one is the aldehyde or the functional group, and the last one is what? The terminal alcohol. Now, the second carbon, okay, which binds to the aldehyde functional group and the terminal alcohol, this carbon is an asymmetric carbon, which binds with the OH, the hydrogen, the aldehyde functional group, and the terminal carbon. All of them differ from each other. And this carbon is an asymmetric carbon. Now, if a compound has one asymmetric carbon, it can able to exhibit optical isomerism. And this compound may have D and L form. And now we are looking at the asymmetric carbon, the second carbon. If the OH is on the right position, the compound is named as D. Now here it becomes D-glyceraldehyde. If OH is on the left at the asymmetric carbon, the compound becomes L-glyceraldehyde. Now we are looking if a compound has more than one asymmetric carbon. If a compound will have more than one asymmetric carbon, the criteria is we will look the asymmetric carbon. We will look the asymmetric carbon which is farthest from the functional group. Here we do have glucose. Okay, here we do have glucose, and the glucose has 6 carbons, as you know. The first one is the functional group, and the second carbon, 1 asymmetric carbon now. Okay, 2 asymmetric carbons, 3 asymmetric carbon, and 4 asymmetric carbon. Glucose has 4 asymmetric carbons, and which carbon is the farthest asymmetric carbon? The one which is positioned at carbon number 5. If you start from the aldehyde functional group, 1, 2, 3, and the last one is the terminal carbon. Next to that, the 5th carbon is the asymmetric carbon, which is farthest from what? The functional group. Now, if you look at the OH position, OH is on the right. It becomes D-glucose. If OH is on the left, on the 5th carbon, the glucose molecule is named as L-glucose. Here, mind you, optical isomerism is only to refer what? Only to refer the position of OH. That means spatial arrangement of OH with that of the asymmetric carbon. Only the spatial arrangement of the OH with that of the asymmetric carbon to designate the given monosaccharide D or L. And in nature, D form of simple sugars are the most dominant ones. And our body can identify it. Okay? Our body can identify it. And even Even our enzymes, okay, our enzymes once can identify whether a molecule is D or L. For example, the major enzyme for glycogen synthesis is glycogen synthase. This enzyme only synthesizes glycogen if the glucose is D4. If it is L4, it will not be able to synthesize glycogen. Therefore, our body can identify it. Okay. Therefore, you know aspartame. Aspartame is made from 2 amino acids. Okay, and aspartame is given for those DM patients. Okay, for DM patients, since it can act as a sweet agent. But the sweetest one is if the aspartame is made in LL form. That means the spatial arrangement of atoms with that of the molecule should be LL. If it is DL, it's not as such sweet. Therefore, our bodies can identify it. Okay. The other is optical activity. Optical activity. The first one is optical isomerism. On optical isomerism, only we will look what the spatial arrangement of OH with that carbon. In optical activity, we will look if a molecule which has one asymmetric carbon, and if you put this molecule on plane polarized light, the polarized light may rotate on the right direction or it may rotate to the left direction. That means if the plane polarized light moves to the right direction, that's dextrorotatory, and it is designated by plus sign. It is designated by plus sign. Now, optical activity is designated by what? Plus sign or minus sign. If the plane polarized light moves to the right direction, dextrorotatory, it is designated by plus sign. If it moves to the left direction, that's levorotatory, it becomes minus sign. Don't indicate optical activity by D or L sign, okay? It is designated by plus or minus sign. D and L only refers to what? Optical isomerism, not optical activity. Plus or minus sign indicates what? Optical activity. For example, if you do have glucose, that's D-glucose, it rotates on the right direction, it's dextrorotatory. If it is on the left, it becomes what? Levorotatory, like fructose. Stereoisomerism is simply to study spatial arrangement of molecules. Okay, stereoisomers has the same order, the same type of bonds, but different spatial arrangements, and will have different type of properties. And our body will tell the difference on it. Now, what are enantiomers? Enantiomers is nothing but one is a mirror image of the other. For example, D-glucose and L-glucose. How many chiral carbons are there in glucose? 4. Yeah. The second carbon, the third, the fourth, and the fifth carbons are the asymmetric carbons of glucose. And if you look at the position of OH in D-glucose and L-glucose, one is the mirror image of the other. If in D-glucose, the OH on second carbon is on the right, and L-glucose is the left. In D-glucose, the third carbon is on the left. Here in L-glucose, it becomes on the right. That means one is a mirror image of the other. These compounds are named as enantiomers. The best example is L-glucose and D-glucose they are enantiomers of each other. The others, epimers. Okay, epimers they are stereoisomers in which two sugars differ in a configuration at only in one chiral center. They have the same spatial arrangement of OH in all asymmetric carbon except in one asymmetric carbon, and you should indicate that asymmetric carbon number also. Okay. For example, D-glucose and D-mannose. Here in D-glucose, this is the second carbon. Okay, the red one. This is the second carbon. This one is the aldehyde group is the first carbon. Next, second carbon. Now on second carbon, the position of OH in D-glucose is on the right, whereas in D-mannose it becomes the left. The rest arrangement is similar. Now D-glucose and D-mannose they are C2 epimers. C2 to refer what? They share the same arrangements of OH except at chiral number 2. Okay. If if pair of isomers that have opposite configuration at one or more chiral centers, but if it is not a mirror image of the other, it's named as diastomers. The best example here is D-mannose and D-galactose. It differs in more than one chiral carbon special arrangement of OH, and at the same time, it's not as such mirror image of the other. It's named as diastomers. When you see the cyclization of glucose, almost less than 1% of glucose can be found in open chain. Rather, glucose can be found in a ring form in our body. And when glucose forms rings-like structures on the carbonyl carbon, okay, this carbon number 1, the OH may be up or may be down. If the OH is down, which is the opposite of CH2OH, the last terminal carbon, the D-glucose is named as alpha 1. Alpha indicates what? Alpha and beta is they are anomers of each other. They have the same arrangement of OH except on the anomeric carbon. On the anomeric carbon, at carbon number 1, in alpha D-glucose, OH is down. In beta form, the OH is up. Can you hear me? Okay. Now let's see D-glucose. Okay. Let's see one by one. Glucose it is analdose sugar. Okay. It's analdohexose. Hexose to refer what? The number of carbon is 6. Aldo indicates the functional group of glucose. It has analdehyde functional group. And the common name of glucose clinically is named as dextrose. Okay. Glucose, synonymously, it's named as dextrose, or it's named as blood sugar, and can be useful as source of energy for our brain and red blood cells. And it can be useful as building blocks of disaccharides and polysaccharides. And this D-glucose is a type of sugar which is present in our blood. And this is some of the normal value of D-glucose in our blood. If an individual may have his fasting blood glucose level may be more than 125, the individual develops what? Hyperglycemia. And this hyperglycemia is one of the clinical indication of DM patients. And the glucose reduced compound has bond energy in its structures. Therefore, whenever glucose is oxidized, it will produce what? High amount of ATPs. And glucose is, as you know, it is universal fuel for fetus. And these are some of the cells which are totally dependent on glucose as energy sources. Now, if someone eats enough amount of carbohydrate, therefore after well-fed conditions, some of the free and excess body glucose can be transformed into a reservoir for next use as glycogen. In case of plants, it can be stored as starch. For us, excess glucose may be stored in the form of glycogen, or it may be changed into what? Fats. Glucose still in excess can be transformed into what? Fats, mainly in the form of triacylglycerol, and storage here it's unlimited. Therefore, it's better to take optimal amount of carbohydrates.
እየተሰማን አይደለም? እየተሰማን አይደለም? ሄሎ